As companies expand to the cloud, asset visibility worsens. The Jupyter One Cyber Asset Management Platform helps you get it back. Jupyter One provides context, understanding, and visibility into your entire cyber asset attack surface. With over 150 integrations, including AWS, Google Cloud, Azure, and more, Jupyter One helps you answer complex security and infrastructure questions, understand the contextual relationships between assets, and build the foundation for your security program. Try it for yourself. Get started with your free Jupyter One account today.
Welcome to another episode of Cloud Security Podcast. And today we're talking about all things confidential data in Azure. And for this, we have, I'm not going to spoil the surprise for you. So I'm going to play the intro song and let's get into this. So let's just get this. Hey, welcome, Steve. How are you?
Good to be here. Thank you, Ashish.
Thanks for coming in. And I am all excited about the confidential data and the Azure space. But maybe to start off with, for people who do not know who Steve or Orrin is, could you tell us a bit about yourself and where you are, your professional background?
Absolutely. So I'm the Federal Chief Technology Officer for Intel Corporation. And in that role, I drive all of our technology engagements, solution architectures, and technologies for the U.S. federal government and the broader public sector. My background is in cybersecurity, having run both security startups in my early career, as well as running security pathfinding and product development for Intel for a number of years as well, prior to coming to the CTO role. So I straddle both sides of the cybersecurity problem, as well as specifically looking at how can we help the federal government achieve their goals with technology and technology architectures.
That's awesome. And worthwhile calling out as well. I think you're definitely the right person for talking about federal government, because a lot of people would not even know why people talk about federal government separately and why is there a need for even them to be addressed separately. So maybe that could be a good point, because I imagine people who are listening into this going, I can trust Azure with confidential data, but there would be people out there who, I would obviously agree that there's a different kinds of data as well. So before we get into all of that, why is federal government, or no, not, I was going to say, why is federal government weird? They're not weird, but why are federal organizations different from, say, regular organizations that we interact and see on our day-to-day basis?
So there's a lot to unpack with that one, but it's a very foundational question. What's different about government applications, government data? So on the one hand, there's definitely a regulatory requirement from the government as far as how you handle applications, how you handle data, how the systems are authorized to be able to operate. And it goes down to, at the core, it's around security. It's around trust. And the reason being is that government data has a criticality to it, whether it be citizen services, making sure that transportation happens, the water treatment, to be able to ensure regulatory regimes are able to operate, to the military and intelligence community that have sensitive data and critical data to the security of the nation that have to be protected from targeted adversaries. And so the level of threat on government systems and government data, really globally, any government has the same set of type of requirements that are different than what you find in the private sector in financial services, healthcare. They all have sensitive data. They all have regulatory requirements. But the federal government typically is a much higher bar for the systems. And they also have a lot more organization around the controls that are put in place. There's laws in place. The FISMA, which is the Federal Information Security and Management Act that was passed a number of years ago, sets forth a set of guidelines of how you protect systems, applications, and data for the federal government. And so there are legal requirements that the government has to adhere to that go beyond just, well, is it somebody I can trust? Now, the providers of services to the government adhere to those regulations. So you have federal versions of the Azure cloud and of the other cloud providers in order to be able to host cloud workloads on behalf of the government. And it's a separate environment that's been certified with the proper security controls and overviews and audits to meet those higher level requirements.
Right. And maybe another one for this, then, I guess, to your point, for people who are, or maybe organizations that are working with the federal government, They obviously have to adhere to federal standards as well. And people normally use government agencies and federal very interchangeably. Are they the same thing?
So yes, I mean, in some ways, you think about the government is is the body that encompasses everything. Federal is typically the marketplace or the vertical, is when you talk about the federal market, because the federal will encompass not just the government itself, the agencies, the departments, the services, but also the ecosystem. So the large system integrators, the service providers are part of the sort of federal market. Sometimes sometimes they're referred to the defense industrial base. It's a broader than that because that also includes, organizations that serve as Department of Commerce or Department of Treasury are also part of the federal market. And so a lot of times you'll think about federal or public sectors. Another term that's often used is the overall marketplace and all the different players in that marketplace. And then government is, the actual government, the agencies themselves. And you find in most, whether it be the US, UK, Germany, any other, India, there's a similar model. There's the government agencies themselves, and then there's the service providers and system integrators that service that federal government in that specific geolocation.
Right. And what makes them different when moving to the cloud compared to, say, a private company?
So there's a couple of different things, and really, in the early days, the government couldn't adopt cloud because the cloud could not meet the security and trust requirements, as well as the contractual requirements of how applications operate in the cloud. Think about the standard application you run in the cloud. It's a service model. It's a subscription. You don't buy a system. You buy time, or if you will, you buy the availability of your service for 20 minutes while you have it up and running. And you're buying compute as a service. You're buying application servicing as a service. Most federal agencies and government back pre-cloud, the way they bought things was they buy a thing. It's a server in a box that they then deploy. It's an airplane that gets put onto a base. And so the way the contracts were stood up was that's how they had to buy things. And so there was one part was changing the way the government buys things to be more service oriented. That took a fundamental shift in the contract language. Then marrying that with the government has specific security requirements that are much more stringent than you find in the public markets. And so having that codified, and what FedRAMP, which was the standard that was put forth by the US government, and really FedRAMP became the model that many other global governments have used for their own security standards, did three very important things. It created a contract structure to do services as a contract vehicle so that a Amazon or a Microsoft or Google or Oracle could sell their cloud services as opposed to selling a server or a piece of software. And then they also codified 153 odd controls that had to be in place to be able to operate a secure cloud on behalf of the government. Everything from not being connected to the internet for certain aspects or having certain default passwords. It was a pretty robust set of controls that NIST, the National Institute of Standards and Technology, put out around how do you secure a cloud to meet the government requirements. And then the last piece was how do you then operate a cloud? And that's what the authorities to run that service with the security, to give the cloud provider the authority to do that on behalf of the government. And here was the key trick that I think was most important. In most government places, if I were to go buy an application or buy a system, I need to certify it that it's secure and that I can run it. And I did that for my program. So I'm a Department of Treasury, this subunit that does fraud detection, I bought that. If the next agency over wanted to buy the exact same software, they'd have to go through the same process all over again. It could take 6 more months. That is not how the cloud works. It's it's the same thing for everybody. And so what FedRAMP introduced was this authority to operate, where as long as you've gotten it done once, you can reuse that authority across different agencies. So it sped the time to market so that once we figured out how to get our application into the cloud, then that same application in that same cloud provider could work for any of the services in that organization.
Oh, that is really fascinating, by the way. And I love how you put it across, because I did not even realize the foundational changes to the service model. And now, since you explained that way, it totally makes sense. Yeah. That government wanted, I don't know, I'm just making it up, but I want a barrel of oil from somewhere. How many barrels do you want? I have 50,000 barrels or 50 million barrels. Oh, great. You don't say, I just want 1 liter right now or one gallon right now, but because that's what I want to use. You can come back to me later for the whole barrel. And be like, doesn't work like that. So
Exactly. And
I don't know
I'll
that.
give you a fun example. In the early days when the cloud was taking off and some of the agencies wanted to buy cloud before this was all codified, I won't name the agency, but there was a particular agency that bought cloud. They bought 36 of them. They basically had cloud architectures running in a hosted environment, and each one was their own separate cloud. But because they had a virtualized environment, but they didn't have a cloud. What they had was a bunch of virtualized data centers across multiple hosting providers on different contracts. It was very inefficient because that was the only way their financial systems allowed them to buy. They couldn't buy a service. They had to buy a thing that they could put someplace. They knew how to get somebody else to host it, so that was allowed, but you had to buy a new one every time. And that was just, that was part of what FedRAMP solved. That really opened the door for the big cloud providers and even tier 2 cloud providers to service the federal government.
It's pretty interesting because to what you were saying earlier, where a federal government or a government agency would have a lot more stringent requirement for what data can go in. They can also have a lot of stringent requirement for how the infrastructure is structured and how data goes in, goes out. I would have thought they would have been probably the first ones to go into cloud if it was possible. And I mean, that's just me thinking out loud because the way it was sold, at least to the private industry, the cloud has elasticity and all these other features outside of the whole service remit. Do you feel that the government would have, I mean, if this was already solved before, government would have been the first ones and they would have, because, I mean, I guess, why would they go to the cloud even now, because what was their reasoning for going into cloud versus the private industry?
So I think, and you'll see it now where there's huge government contracts for cloud and there's, $10 billion size contracts. They're all in. Part of the challenges, like you said, is understanding how do you operate your application in the cloud. They were early in the sense that they had this cloud first that, under the Obama administration had put forth a budgetary incentive to going to some form of cloud to try to get them off the ground, but they still were late. And a lot of times when you think about it is that at the end of the day, the same reason why a bank wants to go to the cloud, for operational efficiency, reducing infrastructure, saving cost, reusability, those same benefits are why the government wants to go to the cloud. The challenge that a lot of times is that government applications, the data isn't open. It's not like in some S3, EC2 or S3 database I can just sort of grab. It's in a protected silo. My application development is oftentimes happening in a custom environment. And so there took a lot of legacy infrastructure modernization to get their systems ready to be able to operate with the cloud. Even little things like thinking about how do you transfer the data from a ship to the cloud when your pipe is this small. And so thinking about how you structure the applications to make them cloud ready. And that's where a lot of the past several years, and a great example of this is the work being done in the Air Force with what they call Platform Run and a program called Kessel Run. And what those two did is created a PaaS environment for building cloud apps. And then they drove an agile process through it to actually be able to take their existing, mission applications and cloudify them. But it took a concerted effort to do that.
Wow. Wait, so have you heard of something called Cloud Center of Excellence by any chance?
Mm-hmm.
So is this very similar to that? Like basically the Air Force made a version of Cloud Center of Excellence for themselves, but this is for mission critical applications.
Exactly, for everything across what the Air Force mission was. And so they built their own cloud infrastructure as center of excellence, but they also had to marry with that the agile processes for doing application development, a PaaS environment that had not just the APIs, but also then the marketplace to drive the tools that they wanted to leverage. And so third-party vendors would then bring their products, similar to like an Azure marketplace, to the Platform One marketplace, that then they could drive that application usability across it. It was there's a lot of papers written about how the success of the initial phase. Of course, now the big challenge is how do you then operationalize that at scale? It worked great within the boundaries. Now the next phase of that is, okay, let's make that enterprise-wide.
Yeah, and Another layer to add to this is the data space as well, because I guess a customer of a government agency, people like you, me, and everyone else who's listening in, probably not government, non-government employees as well, all our confidential data going into, well, I guess I'm not going to go into how many people trust government with the data, but let's just assume some people do. And it also begs the question then, were there gaps in the way cloud were handling data? Is that why? And I want to get into the whole the computing side, so the confidential computing side of Azure as well. So coming from that perspective, with the confidential data, was there a gap already existing, and that's why the the CSPs of the world kind of went in that direction? So maybe the first question is, how good were they in handling data in cloud, considering they were a bit delayed, but they had other challenges from a security perspective? How was confidential data being handled by federal agencies in the cloud to begin with, and what were the gaps?
So you make a good point. Let's sort of look back at what was the challenge that led to confidential computing.
Yeah.
If you look at data security, there's sort of what we call the three legs to that stool. There's data at rest, and that's typically full disk encryption, file encryption, those kind of technologies to protect data when it's being stored. There's data in transit, which is your TLS sessions for web, your IPsec VPN tunnels, point-to-point encryption. That's how you protect data as it's moving around. The last piece of the puzzle that was not well solved is data in use. How do I protect data while it's being transacted upon? Now, that is a problem set. Now, here's the thing. Going back pre-cloud, the way I protected data in use is I had, in a room with a system that I controlled with a guard with a gun and locks on the doors. And therefore, I didn't have to worry about someone physically accessing the system or some piece of malware getting in and scanning the memory, because I owned the system. So I was responsible for the security. And so therefore, I could protect the data on that system when it's being transacted. When it's turned off and I leave the room, data encryption. When I'm sending it to you, data in transit. But the old model of a siloed sort of on-prem system sort of dealt with at least enough of the risk to justify what the lack of extra security. We had technologies, and for the high-end security things where there is a strong threat, you'd have HSMs. That's a great example of a hardware security module, so that you could have the keys, even when they're being used, always encrypted in a protected space, because even you don't want to trust the guard on the front door to the keys to the kingdom.
Yep.
Well, now we move to the cloud, and now it's not my system in my data center with my guards and my guns. It's somebody else's data center. And it's not only that, it's not just my stuff, it's everyone else that I'm sharing that environment with. Yep. So now suddenly I need to have an elevated level of security for the data as it's being worked on in my VM. Even though, because my VM is sharing resources, network, infrastructure, and sometimes the server with other, even in the government, that may have different policies or different security for their application. No one wants to trust everything about everyone else. And then also I'm trusting you, the cloud provider. I'm trusting Azure. And from a liability perspective, Azure doesn't want to have access to the top secret information that's mission critical for the government. And so it really elucidated the need for having a different way of approaching data and use protection. And that's where companies like Intel came in with a hardware-based technology that provided that confidential computing. And at its core, it's the industry term we call is a trusted execution environment, or TEE. And what that is a physical hardware security feature that will encrypt and control memory for an application while it's running the application. So while your application is running, its memory is being encrypted by the CPU, and access to the memory is being controlled and locked down by the CPU.
Interesting. And you've touched on an interesting point. So when I started in the whole cloud space 6-7 years ago, I remember people would ask about data at rest as well, in terms of when it's on a volume on your AWS or Azure or wherever, is it really being encrypted? And I could never get a straight answer from Azure AWS for, is it really encrypted? Because we unless we tick the box, but is what's really happening at the back? Because there is this level of trust. Yes, you have said there is a, tick the box and you're encrypted, but to what you said about data in use, because you still can't do that for processing that's happening in the memory, even till today. And how do you
trust computing solves? Exactly.
Yeah, that's right. So how do you even go down the path of trusting this? And trust is probably a very strong word for it as well, as to, especially with, like, imagine It's different when it's, oh, my choices for what movie do I want to watch or what food I want versus, oh, my passport information or my driving license. Like that is like life-changing things, right? And you don't really just want that to be hanging around somewhere. So from that perspective, then I love the fact that there was a hardware component created and changing the way data in use was moving. So is that something that has changed the opinion of trust for trust between cloud service provider and the government? Do you feel that's the reason that now we have Azure confidential computing and other services that are there?
I think that's a key part. I think there's one other piece, and there's a term that's used called attestation.
Okay.
And that's an important piece of the puzzle, because using the hardware feature is important and good, and you can select it in the checkbox on your VM subscription. But how do you know it's actually doing that before you give it the secret?
Yeah.
So that's where attestation comes in. It's the old notion of trust but verify. And so what attestation does is when you put your VM into a confidential computing service container, or the enclave, as we call it, the hardware will basically sign and measure that container and attest to you as the relying party, as the agency, or as the application owner, that yes, your workload is running in that secure space. So you can trust it now to access the data, to decrypt the things in memory. And that's a piece of the puzzle. And so when you deploy confidential computing and how you do it at scale, you're also deploying an attestation service. It's built into the way Azure does it, so that you get that quote, that attestation that allows you to then verify that your application and data are running in that secure environment. And that's a key piece of then how you can now trust the cloud with your super sensitive data, because you have that piece of verification along with the checkbox that you did subscribe to it.
Yeah, almost like a chain of custody for, so this is kind of going. Yeah, okay, fair enough. I've got a few people joining on the Twitter space as well. Hey, Fabian, thanks for coming in, and feel free to drop your question as well, man. So we spoke about trust. We spoke about the gap for data in use as well. And I've been kind of dilly-dallying on the whole Azure compute and Azure confidential computing. What is Azure confidential computing, and how does it fit into the whole federal organization and the security needs of a federal organization?
Sure. So let's start with Azure Confidential Computing. And to be clear, it's available for everybody. So Azure Confidential Computing or ACCS, Azure Confidential Computing Service, is an offering from Microsoft Azure that's available in the public cloud. And so you can subscribe to it for whether it be PCI data, in a credit card environment, HIPAA, medical records. You've got sensitive IP that you want to protect and you want to keep secure. You can use confidential computing from Azure in your normal public cloud, no matter whether you're government or not. The government side also has in their cloud from Azure a government version of confidential computing, specifically because the government has those higher level of requirements as part of their mandate to protect data and to be able to protect it at various different sensitivity levels. So unlike the private industries that may have regulated data, financial information, PII, or medical records, which are all sensitive, in the government space, you typically have multiple layers of classification, sort of secret, classified, top secret, those kind of designations. So there's additional controls that you want to do, including confidential computing as a service. One of the reasons why it's so important to have confidential computing in Azure and in the cloud in general for the federal side is it allows them to open the door to move those data sets into the cloud. What's prevented a lot of the mass adoption of cloud by a lot of the government agencies is they could do, sort of citizen services and a lot of sort of the notification kind of stuff. Like if you want to go to NASA and see the cool pictures from Hubble, you can go to NASA and see the cool pictures of Hubble. But the really sensitive data, like the launch information, they kept that on-prem, or they kept that in a private cloud. By having these additional security controls in the federal clouds, it allows them to now open the door to move more of those applications, the more sensitive ones, into the cloud. And that opens the door to possibilities that they didn't have before. A lot of the interagency collaboration requires sharing of data or sharing of applications, sharing of APIs. It's very hard to do that in a closed on-prem system. The cloud is an enabler. But in order to be able to take my application into the cloud, that has to be able to secure that application for both of our agencies. So one great example of where confidential computing is used is what's called multi-party analytics. So being able to have a secure data set that each party can go in and query without exposing each other to what they're querying or what the data is. And that allows for that collaboration in the cloud environment using confidential computing that opens the door to wholly new applications and capabilities that they couldn't really do other than a manual call somebody on the phone and say, hey, do you see this information on your screen? I mean, that's what we're breaking with being able to do in the cloud now.
Wow. And well, I guess to your point, I would not have thought about this that much, but now since you mentioned it, the collaboration aspect is quite important as well. One of the reasons why I guess some people were sensitive or about going to the cloud was also this as well. Like, for example, Walmart would not want their data to be visible to Amazon, right? So they would go to Azure. But how do you even like say, what if Amazon has some kind of tenterhooks into Azure or whatever? But to your point, something like this as a service allows you to have that attestation and trust to go, oh, as long as I have the chain of custody, I know my data is secure and it's within the boundaries that we have defined over here. And the more I think about Azure confidential computing, the more I imagine these days people want to have applications that are global, obviously. Yeah. And as you said, Azure allows these services. I'm assuming they go beyond just the region or beyond just the country as well, because nowadays collaboration could also mean that Australia has a great relationship with the US. So Australian Army may want to have some kind of a software relationship, let's just say use the word collaboration, with the US Army or US Navy. Can these happen on a global level as well? Is it sharing happening at that level as well?
So again, the Azure cloud environment is not one region only. Their government cloud spans the world, and
right, okay.
And they have the ability. You know, the nice thing about it is using confidential computing. It could be the Australian government, military talking to the U.S. military. It could also be, ANZ Bank talking to Barclays and being able to share data in the confidential data amongst themselves in a cloud environment. It doesn't have to just be government collaboration. You think about cross-domain fraud detection. Having the ability for Barclays Bank and ANZ Bank and and Citibank to be able to collaborate on a fraud piece of information, but at the same time not exposing their own customer data, which they can expose.
Yep.
But being able to share, hey, I'm seeing this kind of fraud activity on a global scale allows them to collaborate on identifying fraud and money laundering and other kinds of nefarious activities that they normally would have to do in a very manual process.
Yeah. And I think that makes me think of another question then. With the data that they're dealing with, sometimes some of that data would be, let's just say, cannot leave the country, because sometimes even can't leave the state. Yep. So how are those kind of scenarios dealt with in such a confidential computing kind of a thing in Azure?
So it's interesting. The idea of data sovereignty is a key thing. And you find this in most governments around the world, whether it be the US, as part of the FISMA requirement says that US government data has to operate and exist inside the boundaries of the US. Similarly, in the EU individual countries have data sovereignty requirements. So German citizen data has to stay in Germany.
Yep.
Australian citizen data has to stay in Australia. Those are requirements that don't really fit well with the whole global cloud idea.
Yeah, that's right.
What some of the controls that you've had, and actually one of the standards that NIST put out early, and I was one of the co-authors of, is what's called How to Do Trusted Cloud with Geolocation. And so it's an architecture for how you can trust the cloud and use attestation at the hardware level paired with geolocation data to be able to say my workload, say the German workload, it has to stay in Germany. And so I can verify the server with geolocation information and physical server information and be able to generate a unique quote, a unique measurement that I can then bind my workload to so that it can only decrypt and only be provisioned to an environment that matches those properties. And so you can enforce data sovereignty from a technical level, and there's standards and architectures, and many of the cloud providers adopt that standard for their infrastructure. Oftentimes what they do is they do that behind the scenes, and then your web interface, when you say, I want my data sovereignty for this location, it's kicking off that technology on the back end. There are other cloud providers that actually took it a step further and said, I'm going to give you access to make your own, to actually do that direct trust relationship and verify it. So cloud providers have taken multiple approaches. To give you one example, IBM Cloud, the software cloud, gives the user, the tenant, the ability to verify the server infrastructure in the geolocation.
Really?
Other cloud providers use the same technology, but they do it on your behalf of you, again, from a simplicity and scale perspective.
Yeah. He must love the easy thing. Just give me a tick box. I'll put the tick box in. I'll just
Exactly.
move on.
Yeah.
I don't want
So yeah,
extra
the
paperwork.
NIST, for those that are interested, it's the NIST Interagency Report 7904 is the trusted geolocation and the cloud architecture that was published
I'll
by
put that
NIST.
in the show notes as well. I think this is a good one. And I've got one more person join in as well. EB Trey has listening in on the Twitter space as well. Thanks for coming in, and feel free to drop in or raise your hand for the questions as well, people. So I love the collaboration angle. I love the angle that now they have come up with, hey, we can do attestation so you know exactly where this is going. To your point then, if I am able to do a geolocation pinning or tagging, how does that work in the context of, because I'm thinking about leaders who are listening in, other CISOs who are listening in going, okay, that's great, but what if someone accidentally tags or shares for some reason the Australian military and US military start talking, and someone in Australia, I don't know, maybe had a moment of weakness, for lack of a better word, and accidentally clicked on a button which gave access to Australian citizen information on that one particular window. Now, would the geo tag pinning, would that prevent that, or do they need to think about control? Because I'm thinking more from a, like, are we actively making controls for this as well, or does Azure take care of all of that as well? That, hey, Ashish, you're having a moment of weakness, stop this. This is not right. What's the play here?
So there's a couple ways to answer that. Part of the way when government agencies set up their cloud environment and they put their controls in place, they also put in or policy controls about how, what's allowed changes, and they can set policies that say certain things can't be changed, or they need two. I mean, one of the things that a lot of the government agencies said is they call it two-man rule, a two-person rule, so that, for instance, changing the requirement on where something can go from a geolocation requires two individuals to check that box, so that someone could, an admin, and that happens, admins make mistake, but it's much less likely that two admins. And then backing into that is, of course, the audit log, that when that change is made, it's not just made in the ether, there's a log and an event, and because it's outside of policy, it would then show up on our dashboard. But here's the really interesting thing about when you pair that geolocation pinning with confidential computing. Because the data is encrypted, even when it's being transacted upon, if someone were to do something and say, I'm going to put my data, and I think I'm going to put it into Australia, and they accidentally click New Zealand instead, because it looked close on the map, and if they're using confidential computing in both places, even though it's physically moved to another location, the data was never exposed in that location because it's encrypted. And so there's a secondary control you can use to protect the exposure of the data while you fix the policy issue about data movement across domains. And so by using these kind of technologies in tandem with each other, you actually build backups for the control. So even if somebody were to, one example is you worry about, what about an insider threat at one of the cloud providers? So an admin gets paid a lot of money to go walk over to a system and pull the memory, or put a probe on it, or tap a USB. That is a risk. What confidential computing does is it doesn't matter. They can't physically see the data because it's encrypted from the CPU out. So even if they put a probe on the memory bus, it's going to be encrypted. If they took the memory away, it's encrypted with a key that only works on that server. So even if I plug the memory in another server, I don't get anything. And so that's why technology and policy work in tandem, so that you have the policies for doing the right thing. And when things don't go right, you have the technology to sort of back you up.
Awesome. And that, well, hopefully no one's having a bachelor party together. So two people don't end up having, oh yeah, this makes a good idea, let's do that. Talking about other challenges in this space for leaders who may be listening to this and going, okay, Azure confidential computing sounds like a great place to go. Attestation, great. I love the fact I can locally encrypt something as well, so my data in use is also encrypted. What do you see as some of the challenges that leaders face when going down the path of using something like this for sensitive data or expanding global operations and stuff? So what are some of the common challenges that you come across that maybe some of my listeners may be interested in?
So I think some of the things we've heard from customers that are looking at it, number one is a certain amount of education. So knowing that you can take advantage of this service. And it is a little different. It's not like you just throw your app into the cloud and you're done. With confidential computing, you got to think about what part of my app or how much of my app do I want to put in the confidential computing service versus the standard cloud. And so it's taking an architectural view. And most of the time, it's either I'm going to put my data into the confidential computing or I'm going to run my query in the confidential. So it's thinking about what part of your application, because it's not like the old school of where I just take a VM from on-prem and throw it in the cloud and magic, it's done. You can put your whole application into confidential computing. More often than not, though, people think about what aspect of the transaction makes sense for that. So there's a little bit of thought.
Right.
The other is then thinking about the more holistic. So it's one thing if I have one application or 100 applications and I'm going to put them into Azure cloud and use confidential computing, I'm good to go. And in that simple case, you're done. The challenge comes in where people are struggling, sort of having to do a little bit more thought is the multi-cloud and the hybrid cloud. So now I've got two different cloud providers. They may both have confidential computing, but how do I link those two together? And so that's an area that Intel's been working on, is sort of how do you do attestation cross-cloud? And so we actually announced at our Vision conference a couple weeks ago something we're calling Project Amber, which is sort of an attestation service. It's the idea of providing a central service that can cross cloud domains so that you can verify an Azure and an IBM cloud with the same REST API and same quoting mechanism to allow you to do multi-cloud. Similarly, that same capabilities, we have open source tools that help you on this to be able to do on-prem attestation and cloud. So when you do from the on-prem to the cloud and back again, you can maintain that secure attestation as your data moves from those to instances. So that's where so confidential computing moving to the hyperscale is where I think the next wave of both challenge and opportunity is, as people look at applications that the world isn't a simple everything in the cloud. It's a hybrid cloud. It's a multi-cloud. It's a services, a SaaS services coming from a variety of places. And you look at the more interesting applications being built in these industries, it is a multi-cloud environment. And that's where the opportunity for confidential computing across cloud domains becomes really interesting.
Do you feel that the cloud service providers would be open to the idea of this? I mean, it's different when it's Australian military and American military and German military. I feel like cloud service providers being private organizations, maybe government can drive this, that'll be great. But do you feel like they would be open to the idea of collaborating between themselves for something like this? Because I imagine attestation standard, I may say, if I'm Amazon, I have my own attestation standard, and Azure might say, oh, we have our own attestation standard. And there is no, I guess, benchmark, and maybe that's what Intel is working towards. Do you find that they would be more open to this?
So I think there are a couple of different drivers. One is the idea of having an open standard will allow for application portability. And that's one of the key asks from all customers, government, financial service. Everyone wants application portability. And so open standards around attestation is the right approach. The good news is the government's actually making it a mandate, because when they're big, the $10 billion government contract that was announced, the JWCC, or Joint Warfighter Cloud Computing Service, it's got 4 cloud providers as the providers of that service. So by definition, they've got to figure out how to interoperate enough to be able to service that one government customer. And so the government, and we're seeing this also in financial services, you don't want to have a situation where one bank and another bank who chose different cloud providers can't do transaction processing with each other. That's just not going to fly. So the customers are driving the cloud providers to drive towards a set of open standards and APIs. The good news is there are APIs for everything. And so whether it be cloud service, the cloud brokers and the cloud CSPs, the cloud security brokers, are able to provide the sort of multi-cloud approaches to whether it be attestation, like in what Intel's building, or even the idea of having a multi-cloud view of your security settings, your controls, your policies, and to be able to push them out. There's a whole industry of security companies that provide that on behalf of the cloud provider. So the waves are happening to get us there. And as more companies and government agencies start adopting cloud, it's going to become a foundational requirement for that interoperability. The cloud providers that will be successful are the ones that recognize how to leverage their services and to be able to push that onto other clouds, so that I could use Azure Confidential Computing on an Amazon workload. I mean, that gives you Amazon a play, but it also gives Azure a play. And so there's going to be that cross-domain part. And I think security probably will be one of those things that drives more of that collaboration.
Yep. And I guess when $10 billion are on the line, I imagine people would change minds as well. Suddenly
Exactly.
everything moves faster when there's billions of dollars in line, I guess. So it's kind of like towards the tail end as well. So I've got a couple more questions. And one thing that keeps coming up now with the current wave of people working from home and everything, zero trust also comes up quite often as well. What role does zero trust play between data and Azure confidential computing?
So it's a really good point. And zero trust is the topic du jour. If you actually look at the recent executive order that came out on cybersecurity from the US government,
Yeah.
right there in clean English, it says, thou shalt do zero trust. Every
Yeah.
agency has to have a plan, has to have a timeline, and has to do zero trust. One of the key things that when you peel back the onion and understand what does it mean to do zero trust, it's not just, well, I need better authentication on my firewalls. That's not what we're talking about. Really what at the core is a data-centric approach to security. It's not, Ashish, we've authenticated you, you're in, good, end of story. It's, Ashish, I'm authenticating you for this piece of data at this moment in time based on your current role. And so it's taking a data approach, because again, the data could live anywhere. It could be in my domain where I've got authentication. It could be external. It could be in the cloud. It could be generated on demand. And so having a policy and a data-centric view drives a zero trust approach, because now I'm authenticating you for this data, not the system you're logging in from or to. Confidential computing is a key component of that, because now I can employ one of the major tenets of zero trust, which is default deny. By having it in a confidential container and verifying your access at that moment in time, I'm saying, do I want to give you access to the data or to the output of the enclave? And if I take away your access, I don't break the application. And so it allows me to have a self-contained security module for the data, independent of the authentication of the user. That enables a zero trust approach.
Okay. And in that case, maybe maybe I should move on to the maturity scale then, because I feel like there's a lot to digest here for a lot of the listeners over here, and it could be overwhelming to go, oh, I have to do so much. Maybe if we strip that down to what is like a level 1, like a level 10, or what do you see as a maturity benchmark that people can go for? People listening for the first time, all right, I've heard about Azure confidential computing from Steve. Sounds like a great idea. I would love to encrypt some things which are in transit and in use as well. So what is level 1 for? Where can they start? And maybe what do you feel would be a maturity that they can go for? Like they would be pretty advanced at that point in time.
So it's a great question. And the good news is that Azure has done a great job of providing easy to integrate capabilities for Azure Confidential Computing. They actually have on the Azure Confidential Computing Service website, they have multiple models. And if you want to do, for instance, multi-party analytics, they have a reference guide to how to set that up. If you want to just do data security for application workloads and just do an enclave, there's a tool that we helped generate for the industry called Grameen. It's an open source tool that basically you take your existing app and dump it into Grameen. And you don't have to worry about it. It handles all the back end of how to connect to an Azure Confidential Computing in an open source way. And so the easy button is to go to the two things. Number one, go to the Azure Confidential Computing site. It's select the confidential computing service as one of your VMs, and then take advantage of one of their templates, basically to move your application in there. And again, from a DevOps perspective and DevSecOps, Grameen is the fast, is what I call the easy button. It basically, you pull that into your development environment, you can put your application in there and then do the DevOps without having to understand, well, what part is confidential or not. It just put your whole app in there. So phase 1, toss your app into Grameen and you're good to go. As you mature and start thinking about how your application, especially in those services applications that are interoperating amongst multiple applications, that's the next level of maturity when you start taking an enterprise architecture view, an application architecture view of putting my data into this confidential computing enclave, putting my transaction into a separate one, and then putting the UI in a third and having them talk to each other so that each one is their separate entity. It's a more advanced approach, but definitely and by the way, a lot of government customers take the easy button. Just put my application in Grameen and let it go, because that, again, fast time to market, it's secure. I get my checkbox. Now I can go do my mission.
Yeah, that would definitely be changing lives for a lot of people as well, because then you don't have to worry about all the complexity that comes with it. Because I imagine a lot of complexity also means a lot of processes that have to be followed, and it just slows down the whole thing. So great way For people who are trying to learn about this as well, where can they learn about confidential computing in the cloud space and security in the cloud space? Where can they find more information about this?
So I'd give you 3 places to start. One is obviously Azure Confidential Computing, or ACCS, is a great starting point. There's a consortium now of all the cloud providers and technology vendors called the Confidential Computing Consortium.
Okay.
And they have a lot of data on all the different cloud providers and how they're doing confidential computing. And then definitely come to Intel and look at Intel Confidential Computing on our website. I'll tell you a little bit about technology and also have direct links to the GitHub to get Grameen and be able to start trying this stuff out.
Awesome. All right, I'll put those link in. So I've got the last end, which is the fun section. I've got 3 questions for you, and these are non-technical questions, right? These are totally meant for for people to know a bit more about Steve. And the thing over here, so the first question is, what do you spend most time on when you're not working on cloud or confidential computing or technology?
So I have 2 young children, so I spend as much time with my young kids as I can. They are 4 and 2, and they keep me young, and they're just fun to be around. And so I try to spend a lot of quality time with my kids. Prior to having kids, I also used to like to play tournament poker.
Oh, wow, really? Tournament level?
Yeah.
Wow, man. Oh,
That was
you're
my
pretty
fun.
good then. Okay, cool. All right. So well, I mean, I love your. I was gonna say, I'm sure you have a poker face that you can more manage really well. Second question: what is something that you're proud of but is not on your social media?
Something I'm proud of and not on my social media. It's a very good one. I think probably, I mean, but I'm most proud of my wife and my children, but that's all over social media. I think some of the things that I've done behind the scenes where I've helped government agencies to be able to protect and deploy and secure their data and be
Yes.
able to scale their systems. And so seeing the benefit of the impact where you help them secure the data and then they were able to go affect the mission. They were able to help, disaster recovery. One of my favorite examples was helping FEMA get better efficiency so they could deploy resources to disaster zones quicker and more efficiently. And so those are the kind of things where you see the impact of your work.
Wait, and when you say disaster zones, you're actually talking about war, famine, like that kind of disaster. You're not talking about
Hurricanes.
like our BCP disaster recovery, right?
No, this is, hurricanes. This is,
Wow.
the oil spill parts. So when FEMA, the Federal Emergency Management Agency, comes in with resources to help people displaced be able to do search and rescue, technology enables them to be able to get connectivity, to be able to stand up environments, to be able to do sort of micro clouds so that people can coordinate on the ground. And so some of the technologies we've worked with there have helped make them more efficient. And really at the end, it makes it faster time to helping people in need. And so those have been some of the really exciting things I've gotten to do that don't get the fanfare.
Yeah, wow. That's really cool. Last question. What's your favorite cuisine or restaurant that you can share?
My favorite cuisine or restaurant. So my favorite cuisine, I am a pizza person. I love pizza.
Oh,
and
nice.
I joke, I grew up in the New Jersey, New York area. So any New York, New Jersey pizza shop is good by me.
Nice. But for some reason, people say that the New York pizza is very different than New Jersey pizza. Is that true?
Only slightly. I think there's better quality in New Jersey, but my New York friends will shoot me for that.
I was gonna say, I'm like, I don't want to start a war here, but quite literally. But thank you so much for this, Steve. So that was pretty much what we had from a questions perspective. Where can people find you and connect with you if they had follow-up questions around confidential computing and what Intel is doing in this space?
So there are 2 ways to reach out to me. Number one, you can find me on LinkedIn at Sorin. So it's linkedin.com/SORRIN. And then the other is, if you go to intel.com/public sector, you'll see all of my content, podcasts, articles, and the like that myself and my team have put out there to learn more.
Awesome. And I'll put them in the show notes as well. But thank you so much for this. This was really, I think I found it really valuable. So thank you so much for doing this for us as well. I can't wait to have you again to talk more about the whole confidential space and how this is evolving. So thank you so much for doing that. And thank you everyone who's kind of tuned in. I'll see everyone tomorrow for the next episode. But for today, have a good one and enjoy the weekend. See ya.
Thank you very much.